Okay, it's Mr. Hanley back with you, and I am in the process of recording a, uh, whoops, uh, I'm in the process, of recording the summer assignment for you all on June 11th, July 11th, and what we'll do is we'll run through some possibilities. We've got the triangle solver, 3, 4, 5 triangle. That is, nope, enter sides first. 3, 4, 5. You can type things that are read in sequentially with the scanner with space between them if you want. That's a scaling triangle where all sides are unequal. That's a special one. That's 3, 4, 5. It's a right triangle. Pretty cool. And let's enter in something that's not a triangle because triangle inequality. The third side can't be greater than the other two sides added together. Let's see a isosceles triangle where two sides are both the same, 5, 5, and 3. And we also have the possibility of an equilateral triangle. So that's good stuff. Exit back to the main. I've got a kind of a fancy menu. It's got the date and time printing out so you can see when I'm doing this. You don't know that about to watch a big World Cup game between England and Croatia. And some great Wimbledon on right now, too. We've got Nadal and Del Potro, and Del Potro's just taking the third set. So very difficult to beat Nadal on in a major, and so it's pretty good sports day here, July 11th. So bounciness, good stuff. And got my Phillies cap. Phillies are resurgent right now in first place, so this is a pretty good sports summer thus far. Let's compute our distance. We have 100 meters or 100 feet. We have a 0.5 bounciness index and 6 bounces, and you can see there's a distance total traveled down, up, down, up, down, up. Let's turn the verbosity on. You don't have to have this in your summer assignment, but over the years, kids have asked me, hey, how do you get these numbers, and why is mine off? So I'm going to repeat it, and you can see that my program is going to display some of the internals, down 100, up 50, down 50, up 25, etc. And so the ball essentially hovers in air, which isn't really practical, but that's how this problem has been stated. There is also a distance for cutoff. I believe mine is 1.0 e to the negative 6, so it's 0.00001. Let's do a situation where that comes into play. So let's do 100, and let's do 0.2. I knew that. I did it on purpose. I just do that to stay humble because, when you're the man, you got to stay humble, right? That's part of life. Bounciness, we have compute distance. Let's go 100.2, but let's go 50 bounces, and that's just too many bounces. All right, maybe it's not too many bounces. Let's go 10.2, and okay, again, just kidding. Didn't do that on purpose. I guess I'm getting excited about this World Cup match coming up. Hopefully England will pull this one out, but you never know. Okay, 10 meters. Let's go 0.1 index. How many bounces? How about 100? Ew. .1 and 50 bounces. Okay. That's what I was trying to get at. I'm not going to bounce 50 times if it's starting at 10 meters. Because eventually it's going to be, the up distance right here is less than our cutoff. And so, in fact, we don't add that in. So we have, in fact, a shorter distance because we know that the ball, eventually, if it doesn't bounce up high enough, we're going to cut off our loop. Okay. My program allows you to set that, set your own threshold. If you want to do that, I think it's a nice touch. Okay, so I can change that threshold, but that's certainly not required for anybody out there. And you can see, we have a different threshold, 0.01. B goes back to the main. We have the perfect number calculator. Nice little sound effect there. 28 is a perfect number. You know, some of the proper factors equals the number itself. Certainly 73 is a deficient number. I bet 12 is what? Abundant. So you can see the number of factors is 16. Boy, that's a neat way I have of printing it out. I've got some style in these things. Find all perfect numbers in a range. Careful with this. My laptop hung up a lot. Really hung up a lot. Oh, cool. 6, 28, and 496 are in the range from 1 to 1,000. But again, as you get bigger, this thing, that can bring your program to a halt. I think we've seen some... Have we seen a perfect number? 100 is classic perfect. I mean, did I say perfect? Abundant. 117 are the factors. Oh, craps. Classic dice game. Let's take instructions. Okay. You need to make wagers 1 number chips. You'll throw 2 6-sided dice. Add up the sum. 2 through 12 instant loser, 7, 11 instant winner. Otherwise, your roll becomes the point. You switch on World Cup here. Go, mighty England, go. And we will make a wager of 20. Okay. I'm sorry if you hear that in the background. Try to keep the volume low. Anyway, there's our 8. And we're going to have to now re-roll an 8 before we roll a 7. Come on. Oh, no, I guess 9 must have been the point. Is my first roll a 9? Very scattered video. Oh, my first roll is a 7. So I won right off the bat, and then I rolled a 3. So I lost right off the bat. That's crapping out when you roll 3 on the... Oh, okay, so 9, 10, 9. Good. So I'm ahead. But like a true gambler, I go in again. Oh. I bet 40 chips, and what do you know, I rolled a 7, and I'm feeling it. I've got the hot dice now. Woo! Blowing those dice. 30. Oh boy, now I have to roll a 5 before I roll a 7, and I didn't. So I'm down to 130. So you see the idea, and again, if you want to look up, Dean Kuhn had showed me how to do color in the console in Java. That's a nice touch with the dice, but don't feel like you have to do the graphical dice. You know, just get the game working. Okay, that's all from Mr. Hanley, summer assignment. And you all should have some fun writing these programs.